So as we're talking about polynomials and expressions, we're going to talk about one additional thing, which is the greatest common factor, or GCF. Just as a reminder, factors are numbers or expressions you can multiply together to get your original. Basically, they divide into your expression or numbered evenly. For example, like with the number 6. Its factors are 2 and 3 because 2 times 3 gives you 6, or even 1 times 6 because 1 times 6 gives you 6. So those are its factors. When we talk about algebra, if I have like x times x plus 1, and that gets me x squared plus x, I could say that this and this are factors of this expression because they multiply together to get me this expression. So what we're going to be talking about is the GCF, and as a little intro, I want to just distribute this out really fast. So remember, when you distribute, you take what's in front and you multiply it by all these terms. So 3x times x squared is 3x cubed, and 3x times 5 is 15x. So factoring out a GCF is basically backwards of what I just did. It's taking this expression and pulling a number out from both of the terms or all of the terms and bringing it to the front. So the way you're going to do this is, there's a couple ways. The way I like to think about it is, what could I divide both of these terms evenly by that I could bring out to the front? I noticed that both numbers are divisible by 3, so the GCF probably has a 3. And I notice I could divide both of them also by an x. See how I could divide this evenly by an x, and I could divide this evenly by an x. If I try to do any more than that, I'm going to run out of x's right here. Like if I tried to divide by x squared, there's not enough x's here to do that. So x is the greatest amount of x's that I can take out. So this right here is the GCF, the greatest common factor, because it's a factor of both the terms, so it's common. It's like the factors that they have in common and the greatest amount of stuff possible. So like the most amount of x's, the biggest numbers that you could divide them both evenly by. So when I divide this by 3x and I divide this by 3x, what's left? 3 over 3 is just a 1, and I don't need to write that. X cubed, but take out an x, is x squared. Here, 15 divided by 3 is a 5, and x divided by x is just 1. I don't need to write that. So notice what I did was I brought the GCF out to the front by basically taking it out of both of these terms. This is the exact opposite of what I did when I distributed. I distributed the 3x to both terms. Factoring out a GCF is taking it back out. Let's do another example of this. So if I wanted to factor out a GCF from this expression, first I need to find the GCF. What could I divide them both evenly by, like the greatest amount of stuff they have in common? I could divide them both by a 5, and that's the highest number possible. And this one has 3 x's, this one has 4. So the most I'll be able to take out would be 3, because I can't take any more than that. So that's my GCF. And then in parentheses, you always want to write down what's left. After I take out the 5x cubed from both of these terms, what's left? Like when I divide this by 5x cubed and I divide this by 5x cubed, what's left over? So 15 divided by 5 is 3. X cubed over x cubed is just canceled. 5 over 5 is just a 1, and if I had 4 x's, take out 3 of them, I'm left with just 1x, because 4 minus 3 is 1. So that's my final answer. This was the GCF that I factored out, and this was what's left after I did that. And you can always check your work by distributing. If I do 5x cubed times 3, will I get 15x cubed? Yes. And if I do 5x cubed times x, will I get 5x to the 4th? And yes, I will. So that's good. We've done this correctly. I want to show you one other way that you may have learned in middle school to find the GCF. And it's okay if you want to do it this way, it just takes a little longer. Some people like to write out all the factors of each of the terms. So like 15 splits into 3 times 5. And x cubed splits into x times x times x. So these are all the factors of that term. And if I were to list out all the factors of this term, 5 just is a 5. X to the 4th splits into x times x times x times x, 4 of them. And then to find the GCF, you just circle what they have in common. They both have a 5, and then they share 1, 2, 3 x's, but that's all I have to circle. And so that helps you see that the GCF is 5 times x times x times x, which is 5x cubed. And then what's left is whatever you haven't circled. So 3 plus x. So if you want to do it that way, feel free. I personally don't like to do all the circling, so I like to just see what can I divide them both evenly by. Whichever way works for you is fine. Let's try another one. So again, I want to factor out the GCF from this expression. So let's just start with the numbers, because there's a lot going on here. What could I divide 32, negative 16, and 40 all by? I could divide them by a 2, but that is not the biggest amount. I could divide them by a 4, but I think the biggest would be an 8, because we want the greatest common factor. All right, now let's look at the x's. This one has x cubed, this one has x squared, this one has x to the 6th. So the most I could take out would be x squared, because there's no more in this one. I know it says greatest and you're kind of picking the least, which is a little confusing, but the most I could take out would be x squared. And as far as the y's go, this is y to the 5th, y to the 4th, and y cubed. So the most that I could do is y cubed, because that's all that this one has. So this, 8x squared y cubed, is my GCF. In parentheses, I'm going to write down what's left. So when I take 32x cubed y to the 5th and I divide it by this, what do I get? 32 divided by 8 is a 4. I had 3 x's, I took out 2, I'm left with 1. Because 3 minus 2 is 1. And I had 5 y's, but I took out 3 of them, so now I have y squared. Because 5 minus 3 is 2. Let's move on to the second term. Negative 16 divided by the 8 is a negative 2. I had x squared, but I took out x squared, so the x's are gone. And y to the 4th, take out y to the 3rd, leaves you with just 1 y. For this last term, 40 divided by 8 is 5. I had 6 x's, that took out 2, which leaves 4. And I had y cubed, but I took out all the y's, so there are no more y's in that last term. There was a lot going on there, but this is my final answer. And again, if I were to distribute it out, I should get back to this. One more time, I want to to show you, and it's okay if you want to go ahead and end the video now, but if you want to write it all out and circle what they have in common, that's fine. It's going to take a while on this one because 32, let's see, I'm going to clear this out. So 32 splits into, what could we do, 8 and 4? But those keep going. 8 splits into 2 and 4, and 4 splits into 2 and 2, and this 4 splits into 2 and 2. So I end up with 2 times 2 times 2 times 2 times 2, 32. Then I've got 3 x's, I'm gonna run out of room, and 5 y's. For this one, I've got 16 would be 4 times 4 or 8 times 2. And each of those 4s splits into 2 times 2. Then I've got 2 x's and 4 y's. 40, I'm going to split it into 4 and 10. You can do it however you want. You'll get to the same thing eventually. 4 splits into 2 and 2. And 10 splits into 2 times 5. Those are all of its factors. Then I've got 6 x's and 3 y's, and that is everything. So now as I do my circling, I've got, what do they all have in common? They've got a 2, and another 2, and another 2, and that's it, because these share 2, but this one only has a 5, so I'm done circling 2's. As far as x's, I can only circle 2 x's. And as far as y's, I could do 1, I could do 2, and I could do 3, but at this point this one's out. So my GCF is 2 times 2 times 2 times x times y times y times y. Which if we simplify that, 2 times 2 times 2 is 8. X times x is x squared. And y times y is y cubed. So that's the same GCF we got before. And then if you want to see what's left over, you just see literally what you haven't circled yet. This one had 2 times 2, which is 4. It had an x and 2 y's, so x, y squared. This one just had 2y left. Oh, and it was minus, be careful there. So minus 2y. And this one had a 5 and then 4 x's, so 5x to the 4th. Okay, so we got to the same thing, just doing a lot of circling, so feel free to do it that way if you want to.